Hey everybody, welcome back to Jim's Garage. This is the second video in the new Homelab series where we're going to be deploying Proxmox onto our Homelab device, and I'm going to talk you through all of the steps as well as some of the recommendations that I have for the device you might want to use and also the configuration of Proxmox itself. I'll also show you how to deploy your first virtual machine as well as an LXC and some of the other configuration options you might want to consider. Now, in the previous video, I gave you some options around some devices I recommend, but I also spoke about some of the things that you should look for when creating a Homelab device, be it one that you've already got, i.e. an old device, one that you may be building for new, a second-hand enterprise server, or something off the shelf. Now, the requirements for Proxmox are pretty lightweight anyway, but obviously if you want to run more on this, you want to have more provisioning, i.e. more cores, more RAM, more storage space. Some of the devices I showed in the previous video were very much bare bones, so if you are using one of those devices, do note that you might run out of some of those and it could limit what you can actually run on your Homelab server. Obviously something with an upgrade path, more RAM slots, more storage space, more CPU, etc. You're going to be able to do more with your Homelab. But to prove a point, I'm going to use what I would consider the sort of bare minimum. I'm going to use a Melee device that I've used in a previous video. It's only got 4 cores, it's using the newest Intel N150. It's got 16 gigabytes of RAM and a 1TB NVMe. Ideally, you'd probably want to get something with at least sort of 8 cores or at least 4 cores and hyperthreading. 16 gigs is okay to get you started, but 32 is probably a good spot if you want to be hosting some additional services, additional virtual machines, etc. And I would recommend having 2 network interface cards. That can be really handy and it gives you the option to easily set up things like a virtual firewall. And also having the ability to have more NVMe drives in there is pretty cool as well. You could either mirror your boot drive and use that single mirror to actually host the operating system for Proxmox itself as well as all the virtual machines. That does give you some redundancy because there isn't an official way to back up Proxmox, albeit you will find unofficial ones with copying certain folder structures on the hypervisor itself. Now, there are a few ways to actually install Proxmox. There's an automatic installer where you can create a configuration file and it will automatically install it. That's good in a headless environment, i.e. where you don't have, say, a GPU or you need to have remote access to the system. You can also do it through a network boot as well. But I'm going to take the easy option, which is what I recommend and kind of what I'm aiming this series at. And that'll be that more traditional method of downloading the ISO. In this case, it's going to be 8.4-1. From the official website, we're going to hit download and download the ISO. You will need to burn this to a USB stick. Now, there are other ways to do this, as I mentioned, but they are more involved, and I might cover that in a later video. You will also notice here that there is Proxmox backup server. I do have an existing video on that is still relevant, so I recommend you go and check that out if you want to be able to back up your virtual machines, your LXCs, etc. after you've installed Proxmox. So once you've downloaded the ISO file, we're going to need to burn that to a USB stick. Now, there are multiple ways to burn this ISO file to a USB stick. The tool that I like to use is called Rufus. So you can just head to the Rufus website and download this, but other alternatives include things like Etcher. Doesn't really matter which one you use, just choose which one you like. Now, the key thing is this is going to wipe the USB stick because it's going to need to partition it when it copies over the ISO file. So in my case, I just simply need to click select the ISO file that I want, hit OK, and then that's pretty much it. I should be able to hit start. Now, it's going to remind me again that it's going to destroy everything on this device, and that's okay. And then it's going to go away and actually install that onto the USB stick. Now, whilst this is right in that image, it's worth pointing out that Proxmox is not the only hypervisor that you can use. There are lots out there. For example, you can actually use a hypervisor on your Windows machine. That's available on Pro and above, I believe. I do have a video on that, but if you're going down the Homelab route, I definitely recommend having something like a dedicated machine that you can install Proxmox on. Other things to note are you can actually use things like TrueNAS or Unraid as a hypervisor, albeit I tend to use those just for storage. Another notable, or at least it was notable, was something like vSphere before it was bastardized by Broadcom. My understanding is that they are going to create another free tier for that, but a lot of those bridges have already been burned within the community. So I generally recommend Proxmox. It's definitely the most popular one in the Homelab space, and I've had a great experience with it over the past few years. In fact, I actually have 3 machines all running Proxmox in a cluster. I'll come on to that later, but if you want to skip ahead, I've already got videos on that. Now, once this has written it to the drive, you're okay to close this down, but you're probably thinking now, well, how do I actually get this onto the device? What is it that I need to do? Well, I'm going to assume that you've just got a bare bones setup. What I mean by that is you've got your ISP router, you've got the machine like me that I'm recording this video on, and then you've got another device that you're looking to install your first Proxmox onto. Now, that device, quite simply, you just want to plug that into your ISP router. That should pick up an IP address via DHCP, and you should be good to go. Now, you don't technically need to give it internet access to do the installer, but you're obviously going to need to have network access to get onto that device post-installation. One thing that's important for doing it this route is to have a GPU or an iGPU, hence why I gave it so much attention in the previous video. Now, you can do it without a GPU. Sometimes certain devices have things like IPMI, whereby it's able to send the output of the machine over the network and you can view that. But having something like an integrated GPU is a great start because you can simply plug in an HDMI cable like you would normally do, and you'll just get this as output to a monitor. If you're using something like an AMD system that you've built yourself, a lot of the time those CPUs don't come with an iGPU, so you will actually have to use a discrete GPU for that installation process, but you can remove that post-installation because you'll be connecting to this thing through the web browser anyway, or backup via SSH. So now with your machine plugged in, it's time to boot it up, and we want to enter the BIOS to begin with. This is important because we need to make sure that we've got the right boot options selected. By default, it's probably going to boot to the hard drive that the device was set up or came pre-configured with. Now, the BIOS for your machine is going to be different depending on motherboard manufacturer, feature set, chipset, CPU, etc. There's a myriad of things, but there's some common things that we want to look out for. Now, on an Intel machine, we want to be looking for things like VTX and VTD. Those want to be enabled. So on my machine, this was on the VTD section here. You can see that that's enabled, and I've also got VTX enabled as well in another section in the BIOS. The next thing really you want to have a look at is to go to the boot section. And here you can see that I've got Ubuntu installed from when I tested this device, and the boot option 2 is that UEFI USB drive that I just installed Proxmox to. So what we need to do is basically swap these around so that the first boot device is actually the USB device. On some machines as well, you also get the option to fast boot, and you can boot that from a different device without having to change these settings. I'm just going to change this now just to make it easier and make it permanent. Do remember in the future though, if you plug in a USB device, it might try to boot off that, so you might want to swap these around again afterwards. But effectively, all we need to do now is click Save Changes and Exit. That should save it, reboot the device, and now hopefully, as you can see, it's now trying to boot into Proxmox. Now I'm going to talk you through sort of a beginner setup for Proxmox, but do go and read the documentation. There's a ton of other options. This should be able to get you up and running without too many issues, but once you do start to get down this path and get more familiar, you might want to revisit it. If we have a look at the advanced options, you can see that there's automated installations, which I mentioned before. There's also some memory testing and some firmware settings. If you've got, say, a second-hand server from eBay or something, you may wish to run a memory test first to make sure that all of your memory is performing as expected. Otherwise, you could get some crashes or bad behavior once you're going through it. Now, we're going to go for the graphical output, just because it's easier with a graphic interface. Now it's going to boot actually into the installer, and we're going to go through the setup wizard to get this up and running. Now, once this is booted, we have to agree to the EULA, and then we need to choose which device we want to install it on. Now, because this is a cheap device and it only has one NVMe slot, you can see here that I've only got this one option. If you have more than one device, you will be able to click on the options selection here, and you'll be able to choose how you want this set up. So, for example, you can set this up as ZFS, and you've got various different ways to do RAID, and also BTRFS. This would then give you the opportunity to configure and set up and install this to a RAID. That would mean that, in my instance, I've only got one drive. If that fails, I lose everything. But if you have a mirrored drive, a redundant pair, if one of those drives failed, it would simply be using the other drive and you could replace it and keep your data. That is definitely something to bear in mind, but if you're just starting out in the Homelab space and you've only got a small device with one drive, you should be fine, because by the end of this, we are going to be setting up a 3-2-1 backup strategy. So worst case is you'll lose whatever it is between now and your last backup, but to be honest, if you're backing up regularly, that should be less of an issue. In the future, you'll probably want to go and add another drive in here, make a RAID, rebuild your cluster, etc. And we can discuss that later on in the video series. But for now, I'm just going to use this hard drive here, and I'm going to click next. It's automatically detected where I am just due to having this plugged in. And then it's going to ask me to create a password to log in. This will be the actual administrative console password, the one that we'll be logging into through the web browser in a moment. So with those details entered, we should be able to click next. And then it's asking us what do we want as our management interface. Now again, on most of these devices, if you're just getting a bare bones device or an old machine, it's probably only going to have one network card, one network interface. This one actually has the wired one, the one that I'm using, you can see it's green, and it also has a wireless one. Obviously don't recommend using wireless because of the dropouts, etc., interference, which can make administration a pain, and also connections between VMs and your network, etc., pretty flaky. But also I mentioned in previous video that you might want to add in additional network interface cards. Now that's where it gets quite interesting. You can choose then to have dedicated network cards just for the administration of Proxmox itself, which in a more sort of production setup is what you would have. You would likely have a dedicated interface card that is specifically for the administration of Proxmox, and then you would put all of your containers, VMs, etc. onto different network cards. That also gives you the ability to have different network cards, i.e. different performance based upon the requirements. Just for administration of Proxmox, you really don't need anything fancy. A 1 gig is more than enough, but you might wish to get a cheap, say, Mellanox card or something else, a 10 gig card, and assign that just for your virtual machine, so all of your virtual machines get snappy access to your network. In this scenario here, where I'm choosing the default, what this means is it's basically going to bridge the Proxmox interface and all of my virtual machines on that same network host. Like I say, fine for a home lab, not very production-y, but it's enough to get you guys started. So depending on what you've got, you choose how you want to set this up. Just remember which interface card you're using. Now you can also give this a fully qualified domain name. So for example, I could just call this proxmox.jimsgarage.co.uk. You could choose whatever you wanted on yours as well, based upon what you've got. This will be useful in the future because you'll be able to identify your machine, etc., and you'll be able to use this in the future to actually access this through the web browser, etc. Now the IP address here is actually picked up through DHCP on my router, and you'll probably have a similar setup if you're plugging this into your ISP router. You can obviously create a static map as well on your router if you wanted to, so reserve an IP address. I generally recommend for things like a management interface that you do that, because you want to make sure that your network interface isn't always changing, because often when you need to log into stuff, it's always the time at which things change and it can be a pain to get back up and running. So for this demonstration, I'm just going to be running this on 9.109, and I've also set up my DNS server here, which is actually my Pi-hole. This will probably be picked up if you're just using your ISP router as your ISP router's DNS resolver, but you could put in here, for example, 1.1.1.1 for something like Cloudflare. But it's up to you. You can also change all of these settings at a later date. So if we hit next, we should get into now confirmation and installation. So it's basically confirming everything we've just set up in the wizard, and we're going to automatically reboot after a successful installation. So I'm ready to hit install, and now that should be going away, should be formatting the drives, etc. And then it should be installing Proxmox to that single NVMe drive I've got on my machine. Once this is done, it's going to reboot, and I'll see you back on the other side once it's booted Proxmox for the first time. One thing to bear in mind, and this is probably a bit advanced at this stage, but is to understand the kernel version that you're running on Proxmox. Now, basically, the higher the Proxmox version, the newer the kernel. And for the uninitiated, the kernel is essentially the bit of the computer, the code that actually talks between the operating system and the underlying hardware. So it gives things like the OS access to the graphics card. Now, in my instance, and from my testing in a previous video, the actual iGPU in the N150 is too new for kernel 6.8. I believe you need kernel 6.11. It's not so much an issue for Proxmox itself, because we're not going to allow Proxmox to use the iGPU. But when you're installing, say, a new virtual machine, and I'll touch again on this later in case you've skipped ahead, when you install, say, a version of Ubuntu, don't use something like 2404 and expect it to work. You can use 2404, but you'll have to update to at least something like 6.11 kernel. Otherwise, the GPU just won't be recognized and you can't use it for pass-through. I'll reference my previous video because that process is still relevant. I'm not going to have time in this video to do iGPU pass-through, but I will speak about the bits that you need to look out for. So now the machine is rebooting, it should now start up. And because I've unplugged the USB drive, it should automatically fail over now to that second one. Here you go, it's picked up Proxmox, and in 2 seconds it should automatically start booting into Proxmox itself. Now, as I mentioned before, Proxmox is command line interface. When you just plug an HDMI in, we're actually going to be accessing this through the web browser on my current machine, i.e. the one I'm currently recording this video on. So now here you can see that we've got the IP address, HTTPS 9.109 port 8006, and that's what we need to connect to now in the web browser. Now we can also log in via the command line interface, and this is good to know in case ever you've got any issues. You should be able to log into here and resolve anything. So for instance, if I log in with root and I put in the password that I set during the installation, if I hit return, you can see that I'm now actually logged in. And just like I mentioned before, if ever used Linux, Proxmox is just installed onto Debian 12 Bookworm. So now you've got basically all of the things you would expect from a standard Linux installation. So I'm going to exit this, and now we're going to navigate to the IP address at the top of the screen via our browser. So if we go back now to the browser that we actually downloaded the ISO from, and we put in the address that we saw, so in my instance that 9.109:8006, remember it's HTTPS, we should be able to reach the web interface for Proxmox. Now you're likely to get a certificate warning, but don't worry about that. It's because it's using a self-signed certificate, but one that isn't valid, i.e. trusted. So we want to hit advanced and we want to click proceed, and then we should get to the login for Proxmox. Now just like I logged into the CLI, we'll use the same credentials. So it will be root and then it will be the password during the installation. You can obviously opt to save the username, and also, just getting ahead of ourselves, you can use different authentication servers if you want a more advanced setup. We're not going to do that in this video. So we'll hit login. It's going to complain that we don't have a valid subscription. That's because Proxmox comes in 2 flavors. Basically the free version that we're using, but there's also an enterprise one which gets regular patching and security updates. We're going to hit OK. You can also disable that warning if you want later on. So now the default, as soon as we get in here, we can see that we're on the data center tab, and it's basically given us all the information about our Proxmox installation. This is technically our cluster, but we only have a cluster of 1 machine. So this is basically a summary of just this 1 machine. If you look at my more recent videos and stuff I've done on the channel, you'll know that I actually have 3 of these machines in what's known as a cluster, and that allows me to do cool stuff like move VMs between different machines. The benefit of that is I can take down 1 machine for maintenance and then move all of my production stuff, all of my VMs, etc. onto a machine that isn't being taken down. And it also does that automatically, not manually. So again, it makes the management of my systems pretty straightforward. So just looking through the data center itself, you'll see a summary of the machine and what's on it at the moment. You can see that we've got basically 0 CPU usage. It's using about 10% of my memory and pretty much 1% of the storage. Very lightweight, very minimalist, just to get Proxmox up and running. And like I said before, this is only a quad-core CPU with 16 gigs of RAM. Now, if we did have a cluster, we could have a look at all the cluster things here. And if you do want to add another machine in the future to join a cluster, it's as simple as creating a cluster first and then getting the join information, going onto that second machine and then adding it to that machine. And once you've clicked join, basically within a few minutes, you should then be able to see both through one user interface. You can see my video around how I've got this configured. I'll link that now. Also Ceph, and this is very much aligned to setting up that cluster. Ceph I've covered extensively on my channel where I run 3 MSO1s for my cluster. Ceph is the distributed storage that allows me to do that hot failover between my virtual machines. That's because all of the nodes that are in my cluster all share the same Ceph storage. This is kind of a decentralized storage. Each one has a replica of each of the other's data. They all basically replicate in real time so that a machine doesn't really care where it is because it's got access to all the up-to-date data. You can also check out the storage here, and you can also add new storage. It supports lots of different storages. You'll also notice here that we can have that Proxmox backup server, so we can actually set that up as server. I've got a video on that as well if you want to go and check that out. That's still valid. Other things that are probably more relevant to you when you're just starting out, you may have a NAS. I'll be covering that in a future video for some network attached storage. You can actually mount NAS storage within Proxmox itself, and even then assign that over to virtual machines, etc. And you can use that specifically for backing up virtual machines manually. To do backups, you'd want to create a backup schedule in here and specify which storage you want to use. Most of the other things in here, like replication, for example, need at least 2 nodes, so we can't do that. High availability is basically the same as well. That's what's going to allow you to have multiple nodes within a cluster, and then basically if you assign it as highly available, it will try to make sure that if one of those nodes goes down, it puts it onto the other node to make it highly available. Other things that are in here, really, we've got some software-defined networking stuff, which I've done a video on. I probably need to update that. It's quite old now, and I didn't really go and scratch the surface on that one. But what that would allow you to do is basically create software-defined networks within Proxmox itself, basically like another virtual switch layer, etc. There is a firewall as well, software firewall within Proxmox that you can use to add some additional rules and security. Don't really find that I need it because I tend to basically route everything through my router, but that is an option, especially if you're going down sort of a more virtualized route. Other things that are useful, but I'm not going to cover in this video, are users. So you can add multiple users to Proxmox. You could add somebody else who you want to say be an admin. You can get API tokens as well for your cluster if you're going to plug this into something else. You can set up 2-factor authentication, put users in groups, look at pools, etc. Give people different roles. So when you create a user, you have to specify which roles that they've got on your cluster. Obviously, this is very much more sort of in the production space, not for a home lab, but it's great that you get all of these tools to play with and learn from. So enough of the overview of this. Let's have a look at the actual node we've got. Remember, this is the data center. So this is the specific machine that I actually installed Proxmox on. And if we go to the summary, we should now see that we've got that 4 times cores for the Intel N150. And we've got 16 gigs of RAM. And it's showing 100 gigs of storage space. That's the default that the partition size for Proxmox is. But if we actually go down on the left here for the disks, we should be able to click on the disks and we can see this one here. Actually, it's only half a terabyte, not a full terabyte. But what that means is we've basically got about 400 gigs for all of our virtual machines and containers. So similarly, if we have a quick look through the user interface, here you'll see that when we click on one of our machines, we get this log down here. This is going to show us everything that's going on the Proxmox host. So for example, when you create a virtual machine, when you start it up, when you shut it down, all of that, you'll get a nice log here. And you can also display more granular detail. If you click on the system log here, it will show you basically everything that's going on. The cool thing with Proxmox as well is that you can actually have a shell into that machine. So before we actually dialed in physically to the machine, but here we're using a SSH connection over onto that machine, so we can do that as well. You'll also notice now that we have all of the system settings. So for example, here we'll see the network. If you remember back to the installation, we had that EMP1S0. That's the physical RJ45 port on this machine. And we also had that wireless over here as well, which isn't enabled. Now, what happens when you install this is it creates a virtual bridge to that physical NIC. And when we actually install virtual machines, by default, it will install it to that VMBR0. We can create additional bridges, so we could create another one. It automatically enumerates it one higher. We can then specify basically the IP address and all of that sort of stuff. And then we can assign it to a bridge port. We can make it VLAN aware, etc. Now, you do need to assign each VMBR, each virtual bridge, to a physical bridge, so we can't actually add another one to this. And do note that if you are going to be doing anything with VLANs, and I'll come onto that in future videos, you will need to make this VLAN aware. If you don't make it VLAN aware, when you try and put a virtual machine onto a VLAN, the actual VLAN tags won't get passed on, it won't understand it, and thus you won't get a valid network address, you won't get any networking on that device. Certificates are basically where we can add certificates to this machine. This is most handy for when you're doing SSH connections to this. Some of my videos where I've used Ansible to deploy to Proxmox, it will use a certificate to connect to it for security reasons, and you can here basically specify your own certificate if you want to. DNS is that DNS that I set up during installation. You can edit this, add more DNS servers if you want to. The host file, again, similarly, is going to show you the host file on this machine. You may have to change this if you have some network changes. The updates tab is important, and this is basically where you update this machine. So if we actually click refresh for the first time and click OK, it's going to go away to the Debian repository as well as the Proxmox ones. And once that's completed, it should show us all the packages that are available for us. Now, as I've just installed this, hopefully there aren't too many. But even with a fresh install, you can see that we've got these packages that are available. To upgrade, it's as simple as just hitting the upgrade. Do bear in mind that a lot of these, you will have to restart your hypervisor, i.e. Proxmox. So if you are running something, do bear in mind that it might need to reboot. Also, if you go down the route of installing something like a virtual firewall, which I've got videos on as well, when you do reboot your hypervisor, you're obviously going to be rebooting your firewall as well, so that will knock out your network. If we go down to the disks, you'll see the disks in here like I mentioned earlier, and then you can also see sort of the virtual partitions you've got on there, the LVMs, the different directories which you can create as well, and also ZFS if you created that earlier, but we know that we didn't. So now that we've gone through the quick summary of our device itself, let's go ahead and let's create our first virtual machine. Now, the eagle-eyed amongst you probably noticed up here, quite handily, we've got create VM and we've got create CT, create a container. We've also got some handy buttons along the top for rebooting this host, shutting down, accessing the shell, etc., and also some bulk actions. Now, you'll also, when we create this virtual machine, pay note to what you've actually got selected here. If you have the node in this instance selected and you hit shutdown, it will shut down the node and all the VMs. Obviously, if you want to shut down just a VM, make sure you've got the VM selected and then click shutdown. Now, to create a VM, you probably think you hit the create VM button. Well, you do, but first of all, you need to download an ISO file. So just like we did for Proxmox itself, let's go and pick an ISO file, let's download that, let's get it running. So just so we've got something to look at here, I'm going to download Ubuntu Desktop. I'll download 2504 just in case we wanted to pass through our iGPU, just because this comes with the latest kernel version that does support the iGPU. Most of you will probably be downloading the server version, which will just be the command line interface. And that's what I predominantly use in my Homelab for all of my things like my Docker server, Kubernetes, etc. Now, what you can do here is just click the download button itself. That will obviously download the ISO locally. And then when you go over to your Proxmox host, you can go to where it says local on the left. This is local storage. And then you can click ISO images, and then you'll be able to upload it. Or you might notice this download from URL, which will cut out one of those steps. So if we click this to start the download, that should start. If it doesn't, we can actually just right click this, copy the link address. We can cancel the one we've got coming down. Head over into Proxmox, download from a URL, paste it in, hit query, and then you can see here it's got that 5.85. So if we hit download, that should now go away and begin that download process. I'll see you once that's completed. So now that's completed, we should be able to close this down. And now we can see here that we've got this ISO file available. So now we can click create a virtual machine and we're ready to start the wizard. I recommend you turn on the advanced just so you can see all of the options. And you will need this available if you're going to be doing some additional things like adding through hardware, etc. Now, a good option that it opens up is obviously the startup boot. So this means that if ever you reboot your Proxmox server, this virtual machine will automatically restart. If you're using something like a firewall virtualized, it's a really good idea to have that on. Otherwise, your network's not going to come up automatically. So for this one, I'm just going to call this one Ubuntu Desktop. And we're ready to move on to the next stage. So for the OS, I'm going to choose the one that we just downloaded. That's that Ubuntu image there. The storage is local. Later on, you can choose different storages for what you want. You can also use things like a network share, for example. And then we get onto the type of operating system it is. So obviously with Ubuntu being a Debian-based system as well, that's of type Linux, and the kernel version is 6.x, which it is. You can also choose on here different ones, so Microsoft Windows and Solaris kernel. So if you are using something like Windows, for example, make sure you change the type of guest OS to Microsoft Windows, and that'll give it better performance through better emulation. So if we click next, we get onto some of the system settings. Now, this is where it can get a little bit tricky, and I'll reference again my video for device pass-through where I go into this in detail. Basically, the default is going to work, but the default is not going to give you the best experience, especially when you're passing through hardware. In fact, when you're passing through hardware, you actually want to change this to a Q35 device, and you also want to change the BIOS over to a C BIOS. Now, people will say, and I've tested it myself, things like the i440FX will still work for pass-through, but it is recommended per the documentation for Q35. Because we're not going to be doing any pass-through, again, check my video if you want to go and do that. We're going to keep everything as default because I think this is the best way to get this up and running. Do note as well that if you go down the Q35 route, so things like Windows 11 for example, it will ask you to start adding TPMs and enrolling keys, and you probably want to go and read up on that. The best thing to do really is to kind of add a TPM, add some storage, but don't auto-enroll the key, and that usually avoids most of the problems you're going to face. The VirtIO SCSI single is going to be fine for this installation. Again, if you're using a Windows VM, if you want to create that, it'll often complain about the VirtIO drivers not being available. So typically you're going to have to attach, say, a USB stick or something like that to your virtual machine when you go through that installation process and have the VirtIO drivers available. So we're going to click next, and then it's going to ask us about that actual disk we want. So I'm going to leave this as SCSI in position 0. I'm going to create the storage on local LVM, which is this one over here. The disk size for this installation, 32 gigs, is going to be fine for this demonstration, but obviously choose something that's going to work for you. You can also expand this later if you start to run out of space, so don't worry about that. Now, some important settings. You want to be able to put on discard, but I believe discard only works when you've got SSD emulation on. And what that basically means is it enables smart things like trim, which allows it to basically claw back unused space from the virtual machine. So by default, the virtual machine will try and claim all of that space, but if it's not using it, it can actually give it back to the hypervisor or back to another VM if that's also configured in this way. Everything else we're going to leave as default and we're going to move on. Do note that there are bandwidth settings as well that you can specify for a virtual machine. So if you've got, say, minimum levels of performance that you want for a virtual machine, you could obviously go in there and tweak the bandwidth per device per VM. If we hit next, we get onto the CPU. Now again, there's a lot to take in here, but let's try and keep it simple. For a machine like mine, and basically anything that is an enterprise, your sockets are always likely to be one, i.e. you've got one socket on your machine and it has one CPU in it. On enterprise servers, you can often get 2, 3 or 4 or even more these days on a motherboard, and so as you scale that up, you'll notice that you'll have more cores available. So I'm going to put this up to 2 just to demonstrate a point. Here you can see that I've got one socket, one core, and one core available. But if I actually put that up to 2 cores, you can see that 2 cores are now available to that virtual machine. So what that means is it would take 1 core from each CPU. But we know that we only have one CPU, so make sure that you actually increase the cores and not the CPU. Now you need to understand the notion of provisioning through a hypervisor. Now you know that we only have 4 cores on here. So you might be surprised that I could actually set 4 cores for this virtual machine. And you might think, well, how does the actual hypervisor still have any cores left? Well, it's because it's a bit like a timeshare, really. It tries to allocate and reserve that much CPU or that much compute time, and if it's available, it will give it to it. It doesn't kind of hard carve that out and say, only this virtual machine can use this core. You can actually pin it and do things like that, but by default it's not going to behave like that. One thing, if you do have an enterprise server with multiple sockets and you're going to actually use cores from different sockets, you probably want to make it NUMA aware, and that's to do with the memory mapping between the different CPU cores. And basically it's a way to enhance the performance when you're distributing workloads across multiple CPUs. We won't need to enable that just for a single CPU, so just leave that off as default. The next thing is where it gets interesting because you have all of these additional flags. And if you do go down the route of doing things like a virtual firewall, for example, it'll often say to make sure that it's got AES encryption available, which is basically hardware offloading for SSL, network inspection, that sort of stuff. Now, what I typically recommend is to go to the drop down here and scroll all the way to the bottom and you should see host. Now, what host will do is basically what it says on the tin. If you think about the Proxmox as the host, do you remember when we looked at the summary, it showed the actual CPU. So what that will do is give it all of the host CPU's capability. So effectively, if you go on the Intel page and look at all the capabilities of the CPU, it will allow the VM to use all of those capabilities. In most cases, that's exactly what you want, so I always set that to host. That will automatically include things like the AES because this CPU supports AES. So I'm going to hit next on that one, and we're going to get to the memory. Now, the memory I'm going to put up to 4096. And then you get the option of whether you want a ballooning device or not. What's a ballooning device? Well, a ballooning device basically allows it to dynamically scale its memory up to that maximum amount. So for example, when the machine first boots, it might only use, say, 1 gig of RAM, but it has a ceiling of 4096. So it can basically keep taking memory until it hits this limit here. Now, what I actually prefer is to not balloon a device, and effectively what that's going to say is, straight off the bat, no matter what, the host is going to lose 4096 4 gigs of memory. Now, the reason I like this is because you don't run into memory problems and you can plan ahead. If you know, for example, this machine's only going to get 4 gigs, you know that on your next machine, you've got minus 4 gigs to play with, and every subsequent VM, for example, you need to do that. If you don't do that and you have ballooning device, virtual machines will get forcibly shut down in order to make sure that the host doesn't crash. It's also important to note that if you're doing any hardware pass-through, you actually need to disable a ballooning device as well as have Q35 on, and you can read that in the instructions and see it in the video I've posted before. After that, we get onto the network setting. So for this, you can see it's defaulted to that VMBR0, and we don't have anything else available. If you had other NICs and other VMBRs, you'd be able to choose that here and have those different options. Now, I'm going to leave everything as default here, but there are some options of note. We will come back to all of this stuff later in the series once we've got things like VLAN set up, because at the moment, I'm assuming you've got just your ISP router and it probably doesn't even have VLAN capability. But essentially what you could do in here is add the VLAN tag here. You can also add the MAC address in here, so it will pick up an IP address that you've set as a static on your firewall. You can also do things like the maximum transition unit and also the rate limit as well. The model is also important. If you don't have the VirtIO drivers for Windows, for example, it's going to complain that it doesn't have a NIC. You can get around that by using something like the old Intel E1000 emulation. But for Ubuntu, this should be absolutely fine with VirtIO. So I'm going to hit next, and it's going to take us to the confirmation page where we'll see everything we've seen here. You can click start after it's been created. Once you hit finish, it will basically create this virtual machine and start it. But I'm just going to click finish for now. We can see it being made, and it should pop up over here on the left when it's done. So by default, virtual machines start with ID 100, and they will increment with each new virtual machine, as well as LXCs. And here you can see that it's now created it, and we've now got some options. So as I said before, when I click on Proxmox, if you click shut down, that will shut down Proxmox. But if you click on this one first, and then all of these change to just be for this virtual machine itself. So it's in a stop state, it's got 2 CPUs, it's got 4 gigs of RAM. We've also got the ability to dive into the console for this. We can see the hardware assigned to this VM. So for example, if we made a mistake, we could click on the RAM, we could edit it, we could add more RAM if we wanted to. Similarly, as I mentioned with that disk space, you can go to the disk action and then you can move the storage, reassign the owner, or in fact resize it to make it larger. Basically, the user experience is very good because the options are pretty similar. They're all in the same place depending on which you click, which is great to see. You can also provision things through Cloud Init. I'm not going to go into that in this video. Do go and check out my previous video. Cloud initialization is basically what it says on the tin. You can effectively create templates of virtual machines and then simply replicate the same virtual machine over and over and over again in a seamless fashion. That's great if you're doing things like testing out a cluster, for example, as you're going to get a repeatable process to deploy multiple virtual machines where you know the setup is going to work. So let's imagine we've looked through that, everything's fine, is what we've wanted, so we can hit start. Now you can hit start here and you won't get any output, or you can actually click the console here and click start now, and this should now give us the user interface as if we've got a monitor plugged into this virtual machine. So what do we want to do? We're going to try or install Ubuntu, and then this would basically go through the standard installation process for Ubuntu, Ubuntu Desktop, or whatever virtual machine you're installing. It should just show up nice and easy within your browser, which is pretty awesome. So as that's booting up, you'll obviously be able to see in the summary now, you're seeing lots of CPU usage. On the Proxmox, that should be about 50% because it's only got 2 of those cores. There you go, 52.72%. Bear in mind that actually installing this, like I say, it's only an N150. It's not going to be extra snappy, but it should be enough to get this up and running. Now let's pretend for a moment that this is all installed and everything is something that's usable. We can actually go to hardware as well. We can add in certain things here if you wanted to. So we could add in, say, for example, a USB device, and we could choose which USB port we want to put in, and then any devices on that port will get passed through to that VM. So for example, as I was mentioning before, if you're trying to install something like Windows, if you actually install the VirtIO drivers to your USB stick, you would go on your Windows 11 virtual machine, you would click add, you'd select that USB device, and then it should be available to install the drivers from within the virtual machine itself. So here you go, you can see we've got the desktop experience for Ubuntu. Let's imagine I've been through this and it's all working, and you've now got Ubuntu up and running, your first virtual machine on your first Proxmox installation, and you'll be able to use this just like a normal machine. You'd probably want to connect to this through some sort of desktop client like VNC for example, but you get the idea. This is now up and running on Proxmox. So you can replicate this process and go and spin up lots of different virtual machines. Obviously keep an eye on your performance, your CPU usage, memory, etc. But there's also something else that I want to show you as well, because sometimes a virtual machine isn't the right answer. I like to use a virtual machine simply because it abstracts the kernel from the host, but sometimes it's a good idea to use an LXC. Now, an LXC is a Linux container, a bit like you might install a virtual machine. You might put Docker and then some containers, i.e. services as containers. You can actually basically create a virtual machine as a container and then run the service inside that. What do I mean by that? Well, it'll effectively give you, when we logged into Proxmox, it'll basically give you a command line interface like that in an LXC, but it will be abstracted from the host. So don't worry about messing about with anything in that LXC. It won't affect the actual underlying host. To get that up and running, we need to follow a similar process. So we can't just go ahead and create a CT, because when it comes to templates, and basically it uses templates, not ISO files, we don't actually have any. So we first need to go away and select some templates. The easiest way to do that really is to go to local, click on CT templates, and then we want to click on this templates button. And you can see here we've got a few options. There are obviously others available, but I'm just going to pick one from here just to make it simple. Now for this demonstration, I'm just going to use the Debian 12 because under the hood, Proxmox is using Debian 12, and the closer you are to basically the underlying operating system, the smaller that image is going to be. So I'm going to click download on there, and let's see how big this is. Looks like it's 121 megs. Once that's completed, much like before, we can actually begin the process. So we'll close that dialog and we'll click create CT. Now the CT is a little bit different to set up, and it's going to behave more like a pre-configured computer. So we're going to give this a host name. I'll just call this one Debian CT. You have the option to make this unprivileged and nesting. Now by default it's unprivileged and it is nesting. Nesting is enabled. Basically, these are security settings. So unprivileged means it's completely abstracted from the host. It doesn't have any permissions, advanced elevation, etc. onto the host. Now, this is a good idea if you're just starting out, and a good idea just in general, really. But there are certain things if you need access to, say, certain hardware, for example, whereby you might actually have to untick this, thus making it a privileged container. Just bear in mind that if it becomes a privileged container, if this is compromised, it could impact the host, and therefore you could have much more serious problems on your hands. It could also impact all of the virtual machines that are also running on there, so do bear that in mind. For this, you are going to need to specify a password. So this is basically because it's creating a new effective operating system on the machine, albeit in a container fashion. It's going to ask for a password, much like we created a password for Proxmox, or you create a password when you install any operating system. So go ahead and create a password for this. Also, like any other Linux operating system, you can also load SSH key files if you want to. So if you've already got SSH keys that you're already using, you can specify those here, or it should be able to just generate some for you, or use the host ones if you leave it blank. I'm going to leave it blank because I'm happy to use that, so we're going to click next. Now the template we're going to use is obviously on that local storage. We don't have any other, and it should be this Debian 12 standard here. As you add more storage options, as you add more templates, these options will grow. Moving on, we get onto the storage space. So I'm just going to make sure this is 16 gigabytes just to avoid any problems. We do also have the notion of access control lists onto that storage as well if you want to go and do that. I'm going to leave that as the default just to keep this simple. We also do have some options for the mount options and whether we want to skip replication or not. I recommend, if much like if you change the advanced on here, leave those as the default to start out with. Next up, we've got the CPU. I'll just give this one core as is the default, but again, you've got CPU limits. So it's not actually core limits this time because it doesn't operate in the same way. Remember, this is a container, not a virtual machine. We're going to get onto the memory. So for this, I've got plenty of memory on here. I'll give it 4 gigs of RAM. And it also asks for whether you want any swap. Now remember, swap is basically if it runs out of RAM, it then starts to write it to the disk. I'll leave this as 512, the recommended, and hit next. And then the network is going to be Eth0, which is typically what you'd see on, say, a bare metal installation. I'm going to leave all the MAC addresses, everything else, the bridge. You could obviously put this on a different bridge as well for an LXC if you wanted to. And you also get the option of VLAN tagging as well. I'm not going to give this a static IP address. I'll let it pick up on DHCP. So because it's on that Eth0 on VMBR0, that's a bridge network, it should pick up another IP address on the same network. Again, we get the options for rate limiting, but I'm not going to bother with that. And then finally, we get the DNS settings. I'm going to leave this to the host settings already set up to my Pi-hole, but you could obviously put in here different DNS settings if you wanted, and you can obviously do that at different LXC or VM levels as well. So if we click next, it's going to ask us to confirm. I'm going to click finish, and that should be pretty quick to finalize. Here you can see it generated those keys because we didn't specify anything, and the task has finished okay. And here on the left, you see that Debian CT. Again, pretty similar options to previously, and we also have a resources tab here as well because you can actually pass through certain devices to an LXC. Now previously this used to be a bit of a mess. You had to get into the command line to get this working, but now for example you can click add and you can do a device pass through, and then you can actually pass the physical location of the device to that CT. So for example, and this is where it gets a little bit tricky with the iGPU on the N150 due to the kernel version of 6.8 not being able to actually use it, we can pass the device through of, say, your GPU through to that CT container, and then it should show up in the CT itself. Let me go to the console now and let's get this started. So we're going to hit start, and then this should boot just like any normal virtual machine. So here you can see we're right in straight away. Now I'm not actually sure what the login will be. I suspect it's root. Let's give that a go. Hitting return, yeah, we can now see that we're logged straight into it. And so now you've got your first CT and your first virtual machine. They're both running at the same time on your first Proxmox installation. Awesome. So now obviously if you wanted to, you've had a little play around, you can obviously shut both of these things down. You could shut this one down as well. And then if you wanted to go and delete those virtual machines, those CTs, it's as simple as just clicking on it, hovering over the more, and then clicking the remove, doing the confirmation, and also then you get to confirm whether or not you'd actually like to purge the job and destroy the unreferenced disks. So i.e. you can delete the virtual machine and leave the disks, or you can actually remove the data as well. That's entirely up to you. Clicking delete, it should take a little while and then it's gone. And then also the same on here, you can shut that down. I think it's actually complaining because it's still got a disk, and yeah, there we go. So if I just go ahead and remove that disk and shut it down, we can then delete that machine. So hopefully that overview and installation of Proxmox was useful. Like I say, that was very much a bare bones overview of Proxmox. I have a ton of videos on my channel about the more advanced features of that, so go and check those out when you're ready. I will also be coming back to many of the features in Proxmox as we move on through this Homelab 2.0 series. Obviously, I've got the Unify and MikroTik network stack coming up, and in that series, I'm going to be checking out all the different things you saw, predominantly things like VLANs, which are going to be most applicable. So we'll get the VLAN set up first in the network, then we'll come back into Proxmox, and then we'll start breaking our network up, network segmentation, putting different virtual machines, different LXCs onto different networks, so that you can have some security and you've got some restrictions through firewall rules between what traffic, what machines can see what, which is really good for security, especially especially if you're going to be doing things like opening up services to the internet via reverse proxies, etc. You want to make sure that that traffic, you have a artificial DMZ, i.e. you don't want things getting in there and then being able to propagate across your network. We'll also set up things like a NAS as well, which again, it's a good idea to put it on its own bespoke network with very granular controls over what can access it and how. Anyway, thank you for watching. Hopefully by now you've got Proxmox set up. In the next video, we're going to be checking out the MikroTik ecosystem. Really excited. It's the first time I've covered it on the channel. Big thank you for MikroTik for sending me some of their devices. Let's see what we can get set up, and then we'll also follow that up by looking at the Unify ecosystem. The whole idea of this is you can have a look at those devices, you can have a look at the ecosystem, and you can choose which one is the right one for you. There's also other vendors out there, but these are the ones I've got to hand. These are generally the ones I recommend, and the ones that you're going to find readily available in the Homelab space. As always, thanks so much for watching. Take care, and I'll see you on the next one.